Hello everyone, my name is Sachin Tripathi, room number 25. I, along with my teammate, will be presenting on the topic of air quality analysis and prediction. The team members include me, myself, roll number 25, Shubham Verma, roll number 27, Harsh Waghela, roll number 30, Prathamesh Gavade, roll number 35, and faculty in charge, Professor Padna Patil. Next slide. The flow of the presentation will be, we'll start with introduction, then we'll discuss dataset description, then implementation, conclusion, and then references. Next slide. So starting with introduction, clean and breathless air is essential for human health. Ensuring good air quality helps prevent disease and enhances overall community health. Air quality impact on social, political, and economical development. Poor air quality can lead to respiratory illness, cardiovascular diseases, and other health problems. Preserving and improving air quality is a priority at both local and global level. Now I request Shubham Verma to cover further part.
Hello everyone, my name is Shubham Verma, roll number 27. I am going to explain about the data set we have used and the parameter we have taken for our studies. There are various parameters in a data set, but we have taken 6 parameters for our prediction model. That is, first is sulfur dioxide. SO2 primarily come from burning sulfur, the sulfur containing fossil fuels and industrial process. The level of SO2 in the air depend on the factor like fuel type and emission control efficiency. The second parameter is nitrogen dioxide. NO2 is produced from combustion primarily in engines and power plants due to the high temperatures that promote the reaction between atmospheric nitrogen and oxygen. Its levels are influenced by traffic, industry, and weather conditions. The third parameter is used respirable suspended particulate matter RSPM. RSPM consists of tiny airborne particles, droplets that can be inhaled into the respiratory system. These particles come from various sources, including industrial emission. The fourth parameter is suspended particulate matter SPM. SPM consists of tiny solid or liquid particles in the air from source like dust and emission. SPM size and composition vary affected by emission and whether inhaling SPM can harm health. Monitoring and controlling SPM levels are vital in for air quality and public health and environment. Fifth parameter is particulate matter 2.5. PM 2.5 comprises ultra fine airborne particles from source like vehicles and industries. This tiny particle can enter lung and cause health problems. AQI is a main parameter of our model. We use all the parameters for predicting AQI index. That is air quality index is a scale that quantifies air quality with a values from 0 to 500. It accesses various pollutants and provide information on health risk. Different categories offer guidance from good to hazardous. It helps people and authorities make decisions about outdoor activities and pollution control. Further part will be explained by Prathamesh Gowde.
Okay, so hello everyone. My name is Prathamesh Gowde, roll number 35, and now I will be explaining about the various function and method used in these projects. So the first library is Pandas. Pandas is a popular data manipulation theory a library in Python. It provides the data structure like data frame and series, which are used to work with the structured data. The common methods of Python. The common methods of pandas library are as follow. The number one is read underscore CSV. The read underscore CSV method is used to read data from CSV, which is common separatory values files into the pandas data frame. It can also handle other delimited text file. The second method is the head. The head method is used to display the first few rows of data frame. It's helpful for quickly inspecting the structures and content of the data. The third method is the info. The info method provides information about the data frame, including data types, non-null values, and memory usage. It's helpful for understanding the data structure and identify the missing value. Okay, the fourth method is describe. The describe method generates summary statistical of the numerical column in the data frame. It provides information on count, mean, standard deviation, minimum, and maximum values. Next slide. Next slide, please. So the next library is SCL Kit Learn, sklearn. The sklearn is a comprehensive library for machine learning in Python. It provides tools for various machine learning tasks, including classification, regression, clustering, dimensional reduction, and model evaluation. So the first method of the sklearn is decision tree classifier. The decision tree classifier is a class in sklearn used to create a decision classifier model for classification tasks. A decision tree are a type of supervised learning algorithm that makes prediction by recursively splitting the data based on the most significant features. The next method is train test split. The train test split function is used to split the data set into the training and testing set. It commonly used for model evaluation when the model is trained one um, uh, on one portion of the data and tested on another. The next method is accuracy score. The accuracy score function is used to measure the classification accuracy of model. It calculates the percentage of correctly predicted labels in a classification task. The next function is Cohen Kappa score. The Cohen Kappa score function calculates the Cohen's Kappa statistic, which is a measure of the agreement between the predicted and true labels. It's often used to access the performance of classification model. Okay, so now the implementation part will be explained by Sachin Tripathi. Thank you. Next slide, please.
Okay, so let's discuss the implementation part. Df.describe function is used to describe the few columns of the data set. It tells about the mean, standard deviation, minimum, and maximum part. Next slide. So this function has been used to calculate the individual pollutant index. This is for SO2. Just like SO2, we have calculated the individual pollutant index for SI, NI, RSPI, and SPMI. And this function is used to calculate the air quality index. So we have compared all the parameters, whichever has the highest value will be considered as the air quality index. Next slide. Now, once we calculated the air quality index, we have classified the air quality into various ranges, which are good, moderate, poor, unhealthy, very unhealthy, and hazardous. Next slide. Uh, After the classification, we have split the data set into two parts, training data set and testing data set. X coordinate tells about the parameters which will be affecting the air quality index, and y coordinate is the actual air quality range class. Next slide. So once the after the splitting of data into training and testing part, the decision tree classifier has been trained with training data set and model is built. And once the model is trained, we predicted the model by providing values like 7.4, 47.7, 78.182, and 100, and it predicted the air quality range as moderate. So this was about the implementation. Now Shubham Verma will cover the visualization part. Shubham, you are on mute.
Hello everyone. In visualization, uh, we have various graphs in this model generated by this. We have first graph is that count of type of area present in the data set. It shows the distribution of area type within specific state to the data set, highlighting the frequency or count of each area type within their respective state. The visualization indicate that the residual area dominate in terms of frequencies. The second graph is shows about the level of SO2 level in the state. It provides a visualization revealing the state with the highest level of sulfur dioxide in the air, with Uttaranchal leading the list and followed by Uttarakhand. In contrast, Mizoram and Nagaland exhibit the lowest SO2 level among the states. Third graph visualize the NO2 level in the state. It represents the high level of NO2 in the air of different states, West Bengal has the highest NO2 levels among all states, and the Tripura and Lakshadweep display a lowest NO2 level in comparison. In the last visualization, we have PM 2.5 level compared to the other state. In this, we can see that the Delhi has the highest PM2 level when compared to the other state. Conversely, state with such as Haryana, Assam, Tripura, Kerala, Punjab, and other states exhibit lower PM2 levels, PM 2.5 levels. In the further part will be explained by Harsh Waghela.
Myself, first Wagela, roll number 30. So, just to conclude, our project effectively demonstrates the use of machine learning algorithms for predicting the air quality index AQI based on wide range of environmental parameters. So, we have used decision tree model, and it stands out for its exceptional performance, offering a well balance between predictive accuracy and model robustness. So it doesn't exhibit significant signs of overfitting, making it reliable choice for AQI prediction in diverse geographical locations. This model serves as the foundation for an early warning system for air quality, benefiting public health by providing timely alerts about air quality deterioration. It also extends its utility to environmental management and policy planning. Next. Hmm. So this predictive model has implication beyond public health, empowering local authorities with real-time and actionable insights to address air pollution effectively. Such system can aid policy makers in crafting more effective air quality control measures, reducing the economic and societal burdens of pollution-related illness. Integration with more advanced monitoring systems, satellite data, and IoT sensor data can further enhance AQI prediction capabilities. The holistic approach has the potential to address the global challenge of air pollution and improve the quality of life in affected regions. Next slide. So these are the website we have referred for data set as well as for research paper. Similar to it. Next slide. Thank you.